Afternoon class, this is 7.4. Unfortunately, at the stop button, I will upload both parts if you so need me to. But just to recap, we are using 7.4, which is proving quadrilateral is a rectangle. We'll also prove that a quadrilateral is a rhombus and also a square. So for now, we're going to use a rectangle, and it asks for two methods to show that the diagonals are congruent, where we can use distance, or use Pythagorean theorem, where it's a squared plus b squared is c squared. And we can use our second method, is using show that is a right angle using slope. And to show that right angle, you have to have perpendicular lines, and the perpendicular slope is using the opposite reciprocal. So for example, if we had 1/2, the perpendicular slope is -2, because you would use the opposite, which means changing its sign. So if it's positive, it now becomes negative. And then I'm going to flip the actual fraction, so I end up with -2/1, which gives me -2. So for proving we have a rectangle using our given vertices, we will graph, create our chart, and make sure we're showing the diagonals. And so we are on to showing the slope of GH. So showing the slope of GH, I'm going to use rise over run. You can use the slope formula. However, it is a lot easier to count, but again, you have options. So I'm going to rise over run, or count, so to speak. So I move over 1, 2, 3, 4, and there's a reason I write 4 here, and I went up 1, 2. So make sure I am using rise over run, so that means I use 2/4, and that does reduce to 1/2. Okay, and so that means IJ must also be the same thing as well. 2/4, which reduces to 1/2. Then I'm going to find the slope of HI. I rose up 2, and I went over 1. So I have 2/1. However, it is not positive. It's actually a negative slope, because my line is decreasing, so it's really a -2. Okay, so there's my slope of each coordinate point, and now I'm going to use the distance. So finding the distance of GH. So remember how we said we can use Pythagorean theorem? I have 4 and 2, so it kind of means I have a small right triangle, and I need to find my slanted distance here. So that means I have 4 squared plus 2 squared equals c squared. So I'm left with 16 plus 4. And make sure I take the square root of both sides. So that means GH is the square root of 20 and IJ is the square root of 20. Then I'll do the same thing with HI. So now I had 2/1, but I can't have negative distance. So even though it says -2, do not put a negative distance. So I have 2 squared plus 1 squared, because I did 2/1. So I'm left with 4 squared plus, or 4 plus 1 is 5, and make sure I take the square root. So I'm left with square root of 5. Then the last thing I need to do is find the distance of my diagonal. So I already have a straight line actually between J and H, so I can actually count. So I count 1, 2, 3, 4, 5. And then I can do the same thing for G and I. So I can always count here 1, 2, 3, and I went up 1, 2, 3, 4. So I pretty much have this triangle right here. There's a reason I put it in pink, because it looks like this. And if you note special right triangles, it would be a 3, 4, 5 triangle. Or you can always do 4 squared, 3 squared, or 16 plus 9 gives me 25, and make sure you take the square root of it. I do end up with 5. There we go. So I have all of my evidence. And so, summarizing, I proved that my diagonals are congruent. So I have GI is congruent to HG because they both equal 5. Then I have to show my perpendicular slope. So which two are perpendicular to each other based on opposite slope? Well, GH is perpendicular to HI, and then IJ is perpendicular to JG. So I showed two sets of right angles. I can also say GH is congruent to JG, or not congruent, they're perpendicular to each other. And I can also show congruent distances. So GH is equal to IJ, and HI is equal to JG based on distance. Okay, so there's all of my evidence to prove a quadrilateral is a rectangle. Alrighty, let's move on to a rhombus. So proving a quadrilateral is a rhombus. Now remember the difference between a rhombus and a square is the right angles. The only right angles that are given are through the diagonals. And I have to show the diagonals are perpendicular. Remember, we're using slope, and that is with opposite reciprocal for perpendicular. Okay? And then I have to prove the adjacent sides are equal. Technically, we don't really need that proof. But we do need to show that all four sides are equal, and that's using distance. Okay, so we prove that a quadrilateral is a rhombus. I need to plot these vertices. So A is -2, 3. B is 2, 6. And C is 7, 6. And D is 3, 3. It looks very similar to a parallelogram, but it is not, because we're going to find out all these distances are the same. So all four have to be equal. So go ahead and draw your chart. Alright, so we also have our diagonals to prove. Remember, we're using slope, not distance this time. Alright, let's get our slope and distance of AB. Technically, we only need the distance, but we can also prove that I have lines that are parallel to each other as well. So the slope of AB, rise of run, I have 1, 2, 3, all over 1, 2, 3, 4. Okay, so I was 1, 2, 3, and walked over 1, 2, 3, 4. So that means the same goes for DC. I have 1, 2, 3, 4, and I rose up 3. Then the slope of any horizontal line is 0. Then to find the distance, remember I made this perfect right triangle, so I have 4 squared plus 3 squared is C squared. So 16 plus 9. 16 plus 9 is 25. Let's take the square root. So 5. So it's BC's difference. I can always count for this one. So I have 1, 2, 3, 4, 5. So I know that all of my distances were the same. Now we need to make sure our diagonals created a perpendicular slope. So note that we have to use rise over run. So let's go from A to C. I rose up 3, and I went over 4, then 5, 6, 7, 8, 9. So 3 over 9, which is the same as 1/2. And that is a positive slope. So that's where 9 came up. 4 plus 5 is 9. Then I'm going to do the same for BD, so I went over 1, and I went up 1, 2, 3. Alright, my mistake, this is actually 3 over 9 is actually 1/3. And then if I do BD, I went over 1 and I rose up 3. However, my line is decreasing, so it is a -3. And these are definitely offset reciprocal to each other. I have a positive 1/3, and the perpendicular slope to that is -3. So, to summarize the evidence I found, so I showed that the diagonals are perpendicular, so BD is perpendicular to AC, and all my distances are the same, so AB equals BC, which equals DC, which equals AD. And I can always show distances, parallel lines. So I have AB is parallel to DC, and BC is parallel to AD. Okay, so that is proving a quadrilateral is a rhombus. So now on to our next page, we're going to prove that a quadrilateral is a square. So proving a quadrilateral is a square. So there are many ways to do this. You must prove that a square is a parallelogram, rectangle, and a rhombus. So remember, this is how we talked about how the rectangle, if a rectangle and a rhombus had a baby, then it would be a square. So rectangle, rhombus gives you a square. Parallelogram, like granddaddy. I recommend proving the opposite sides are parallel. So prove that the opposite sides are parallel. And remember, that's using slope. And then the angles are right angles. So remember that slopes, that's the rectangle side. And if it's perpendicular, you're using opposite reciprocal. So this is where you're showing some that are parallel and some that make perpendicular lines. Because we know a square has the same distance and 4 right angles and yet 2 sets of parallel lines. Alrighty, so I jumped into going ahead and plotting my points and drawing my chart. So I can go ahead and start doing my slope and distance. So we know that from a square, they have all the same distances, and they also have 4 right angles, and have 4 parallel lines, and have 4 sets of right angles, which comes from perpendicular lines. It's a lot to prove, but very little math to do it with. So let's talk about the slope of AB, and so that is rise over run. So I'm rising up 1, 2, 3, and I go over 1, 2, 3, 4. So my slope is 3, 4, and let's see if that same goes for DC. So I went over 1, 2, 3, 4, and I rose up 1, 2, 3. Okay, and so let's do the same for BC. So BC slope, I went over 1, 2, 3, and I went down 1, 2, 3, 4. So remember, I rise over run, so that's 4 over 3. However, I do have negative because BC and AD, they are decreasing. They're going downward in my graph. So these are negative 4/3. All right, so now let's do the distance. So the distance of each one, so we can use Pythagorean theorem for this one. So I have 3 squared plus 4 squared equals c squared. So I have 9 plus 16. We know that's 25. And when I take the square root, c is 5. So the length here is 5. I can do the same thing for DC. No, even though I have a negative slope, I will never have a negative distance. So I still have my 3 and 4, so that means each part of this is also 5. All right, so see, there's not much to show. So for a square, here are my evidence. So let's talk about ones that are parallel to each other, proving opposite sides are parallel. And so remember we said parallel, that means they have the same slope. Perpendicular is opposite and reciprocal. So which ones are parallel or have the same slope? AB is parallel to DC because they have the same slope. And BC is parallel to AD because they have the same slope. Now I need to prove that I have right angles. So that's the opposite and reciprocal. Well, these are definitely opposite and reciprocal because 3 over 4, I take the opposite part, which means if it's positive, it's now negative. So negative 3 over 4. And then I'm going to flip it. So now I have negative 4 over 3, and that does match my reciprocal. So that means AB is perpendicular to BC, and DC is perpendicular to AD. I can also go on to show all 4 right angles. So I have AB is congruent to AD. Or not congruent, it's reciprocal. And then I know BC is a right angle to AB. Or you can also write these all the way around. Or I can say congruent to AD. DC. I show 4 right angles here. You can also write these all at once. So you can say AB is congruent to BC, or perpendicular to BC, perpendicular to AD, and so on and so forth. But you're showing 4 right angles. And then, so I did parallel and perpendicular based on slope, and all of my distances are the same. So I say AB equals BC equals DC equals AD, because all of my distances are the same. And so that is for proving a quadrilateral is a square. So throughout the rest of your packet, you have ones that ask for proving certain things. So this one is a rectangle, so you're going to use those methods. On the other side, you have proving a quadrilateral as a kite, which we'll prove in our next section. So that is 7.5. Okay, and we'll head that one to the next section. And then you have trapezoids on the other one as well. That's also 7.5. So throughout this, you still have parallelogram, which is reviewed from 7.3. Page 18, this is on page 18. There's a square, so you're going to use methods for a square here. On page 19, you have a rhombus. Okay? And then on to our next page, you have a rectangle. On page 20, you have a rectangle, and you have a rhombus again. So these are plenty of practices throughout your packet that we've gone over proving a quadrilateral is a rectangle, a square, and a rhombus. All right, and that concludes our 7.4 notes. And so if you have any questions, you know to find me. I'm here after school Wednesday and Thursday after school from 3 to 4, and you can always catch me on Remind. Thank you.